hydrogen, the sharp sourness tells you it's acidic. If you accidentally get soap in your mouth, the bitter taste tells you it's a base. But if you mix an acid and a base together, it's release positively charged hydrogen ions. But a solitary hydrogen ion is highly unstable and cannot exist alone. The moment it breaks free, it attaches to a surrounding water molecule, creating a stable new structure, the hydronium ion, or H3O+. Bases do the opposite. When dissolved in water, they release negatively charged hydroxide ions, written as OH-. Here is exactly what happens when you mix the two solutions together. The positively charged hydronium and the negatively charged hydroxide collide. They snap together to form plain, neutral water. The remaining molecular fragments from the original acid and base are left behind, bonding together to form a solid crystal structure, known as a salt. Every acid-base neutralization follows this exact pattern. It is simply the collision of hydrogen and hydroxide to make water, while the leftover fragments determine which specific type of salt is left behind. Now let's look at what happens when an acid reacts with a pure metal. When a metal is dropped into an acid, it forcibly takes the place of the hydrogen in the acid's chemical structure. This displacement forms a new salt in the solution, forcing the displaced hydrogen atoms to pair up and escape as pure hydrogen gas. This animation shows a standard laboratory method called the pop test. Because hydrogen gas is invisible and odorless, we prove its presence by bringing a burning candle near the escaping bubbles. Hydrogen is highly combustible, so it ignites with a sharp, distinct pop sound. You can rely on this rule moving forward. Whenever a metal replaces hydrogen in an acidic solution, combustible hydrogen gas is the guaranteed byproduct. We can progress from simple metals to metal carbonates. Because carbonates introduce carbon and oxygen to the reaction, hydrogen gas is no longer the escaping byproduct. Instead, the reaction yields a salt, water, and carbon dioxide gas. To confirm the gas is actually CO2, we pass it through clear lime water. The carbon dioxide reacts with the lime water to form solid calcium carbonate, which turns the entire solution a milky, opaque white. Watch out for this frequent trap on exams. If excess carbon dioxide continues to bubble through that milky solution, it causes a secondary reaction. The white calcium carbonate particles dissolve entirely, turning the liquid completely clear again. Let's test this rule. Pause the video and predict the exact products of reacting hydrochloric acid with sodium hydrogen carbonate. The products are sodium chloride, water, and carbon dioxide. Even though the starting molecule contains hydrogen, the presence of the carbonate group guarantees that carbon dioxide will be the gas produced. We can apply these same reaction principles to synthesize 5 major industrial salts, starting with the baseline, sodium hydrogen carbonate, commonly known as baking soda. Applying heat to baking soda breaks it down into sodium carbonate, water, and carbon dioxide gas, which causes bread to rise. Adding exactly 10 trapped water molecules to that sodium carbonate changes its identity entirely, making the water a permanent structural part of washing soda. Baking soda for cooking and washing soda for cleaning are direct chemical cousins. They share the exact same sodium and carbonate foundation, separated only by the application of heat and the specific count of structural water molecules. Heating gypsum to exactly 100 degrees Celsius sheds 1.5 water molecules, creating plaster of Paris. The formula shows half a water molecule, which seems impossible. In reality, 2 separate calcium sulfate molecules physically share a single whole water molecule between them. Here is a complete cheat sheet for the chapter. Take a screenshot now. The first row contains the core reaction rules, while the second outlines the 5 essential formulas. By identifying the reactant type, you can accurately predict any product on your exam.